So today we are going to look at questions that have to do with the limiting factors. And I'm sure from what we did last time, you remember we also looked at limiting factors, where we looked at throughput accounting. So the difference between what we did last time and what we are going to look at this time round is basically looking at when you have more than one limiting factor. So you have a situation, for example, when you are looking at manufacturing 3 products, but the only thing that the limiting factor is not just maybe the labor, but also the materials. So now in that situation where you have more than one limiting factor, there is no way of you looking at this on an individual basis like we did for throughput accounting. So we normally use what we call linear programming. And linear programming, if you looked at the lesson that I shared, is not something you can do by using calculators. Okay, there are those that can do it, but it requires you to set up equations or inequalities and basically come up with the line of best fit or the wanted region shared and then get an objective function. So it has some steps that you can't really be able to do in an exam setting, except if that exam is a math paper and that's all they are trying to test you on, because it's mathematics. So for that reason, therefore, you will find that in the exam, they won't ask you to calculate a whole number on linear programming, but they are going to give you things that we can look at. And I know some of these questions may have been handled in that video as well. So this will help you to strengthen those points. But let us look at the questions. And the first question we are looking at is question which is from section A. And they are saying that, so they are giving us a couple of products. So as we said, we first go to the section where we have the requirements so that we see what they are asking us to do. So you see that they are saying that if the strike goes ahead, which product or products should be produced if profits are to be maximized? And they're saying tick the boxes to show which ones we can actually produce. So if you go to the question, you see that you have a company which has the following 4 planned products for the next 4 weeks. So the figures reflect the full capacity level of operations. So when you look at that, you need to understand what it means by full capacity level of operations. Then now what we need, they are saying planned output is equal to the maximum demand per unit. So which means that this planned output is also the maximum demand. So you have the selling price, and you see that they are going to be selling at different prices. So you can see some are selling at 160, 214, 100, and 140. So there is that. Then you can now also look at the raw material cost, the labor cost, and the overhead, and the fixed overhead, and then the profit that can be got per unit, and the planned output, which is 300, 125, 240, and 400. But the direct labor hours per unit is this. Now, in this case, they are saying that the direct labor force is threatening to go on strike for 2 weeks out of the forthcoming year, which means that you only have 2160 hours available for production rather than the usual 4320 hours. So, of course, now, in this case, they are telling us that the only thing that is likely to happen is that labor is going to be limited till go on strike. So now they're saying if the strike continues, which product or products should the company actually produce to maximize profits? So this is an example of that situation where you don't have more than one limiting factor. Just have one. In this case, is labor hours. So if we are to set up on our Excel file, just for illustrative purposes, when you are looking at limiting factors, remember that we said that when we are looking at limiting factors, we look at the variable or the contribution per unit. Then we also look at contribution per the limiting factor. So it means that we shall have our products. So we have product A, B, C, and D. The product A, B, C, and D. So we know the selling price is 160. Then raw materials cost and labor and variable overheads. So these are the ones that we need to get contribution. So you can get contribution for A to B, 160 minus 24 minus 66 minus 24. That is for A. Then for B, 215, 214 minus 56 minus 88 minus 18. 214 minus 56, 88, and 18. That gives you 52. And then for C, 100 minus 22, 33, and 24. (22, 33, and 24). And then finally for D, 140 minus 40 minus 22 minus 18. So that gives you our contribution. Okay? Contribution being selling price minus the variable cost. Okay? So now having our contribution, this is contribution per unit. Contribution per unit. Then remember what is limiting in this case is the so what is limiting? It's okay, I'd lost you there. Okay, so we are saying what is limiting in this case is the direct labor hours, because they are threatening to have a strike. So we only have 2160 hours. So it means we need to know how many hours do we need. And they have told us the hours 6, 8, 3, and 2. So labor hours per unit. They've told us we have 6, 8, 3, and 2. Okay, so therefore we need to know contribution per labor hour. Remember, we do contribution per limiting factor. And basically, you just divide contribution per unit, divide by contribution, divide by the labor hours, which gives us those figures. And just to work in the same decimal places, so you have yourself 7.67, 6.57, and 3. Then you can do a ranking. Now the ranking should go to the highest contribution per labor hour, which in this case means that the first one should be A, actually D. This should be number 1, because it started, followed by A, followed by C, and B comes last. Now, when you know this, then you can look at the plan that you should use for production. So we said we start with A. We start with D. Then we go to A. Then we go to C and B. So we need to know how many hours, how many units first of all, then how many hours shall we have used, and the cumulative hours, and the hours remaining. These are just for you to show for you to learn how the process works. If you are doing this section A number, you wouldn't do all these tables and all. You just determine how many hours do you have in total and how do you utilize them. So now, so if we are going to start with D, it means that we are going to produce all of D, because D, we can make 400 units. So 400 units of D, and how much do they consume? They will consume 400 multiplied by 2 hours per unit, which should give us 800. Then cumulative hours, we are going to be summing up the hours that we have used so far. So let me just set up a formula here that's going to help us with that. So it means that at the moment we are at 800, and the hours that are remaining, remember that we have only 2,160. So 2,160. So 2,160 minus the cumulative hours that we have used. So that means that at the start, after I finish D, all the 400 units, we have 1,360 hours remaining. Okay, so far so good. Then we now produce A, and A, we can produce 300 units. And the hours that it can take us to produce A will be 300 units multiplied by 6 hours per unit, which gives us 1,800. And you already see that we can't produce all of the units. You see that we shall have a shortage if we produce 300 units. So which means that in actual sense, what we need to produce as a unit is supposed to be 1,360 divided by the 6. So we are only going to make 227 units. And at this point, you can just stop here and answer your question, because you can't make any other products. So you're going to come here and just say, I'm going to make A and D, whereas these ones I'm not going to make them, okay? And move on. But just because we are learning, so let us finish the whole thing. So because we are now using this as a learning moment. So knowing that you produce A, these are the hours. So the cumulative hours now will be 2,160. And now if I move this one down, you see that I have now no more hours left, which means that I don't make anything else for A, for C, or for B. So this is when you have only one limiting factor. Now, so we have another question here, which now uses linear programming. So here what they have told us that these are the following. This is the contribution function, 5x plus 10y, which means that you want to make 5 times whatever x product is, and 10 times whatever the y product is. This is the contribution function that you want to maximize. Now, the graph has shown you that the optimal plan is at the point where the following two constraints cross. So this is where the optimal point is. Maximum demand is 12,000 units each. And they're saying what units of X of Y should produce in order to maximize contribution. And they're saying the nearest unit. So now, if you have looked at the linear programming video that I shared, you should know that linear programming works by having the inequalities that we said and the objective function, which both have been given to you. And here they have told you also where the two points meet. So basically what you need to solve is these two equations. Now, I don't know which calculators you have, okay? Because I know most of us not being engineers and all, we don't have calculators that can solve the equations. But if you do, then you just solve these two equations and you find the answer. But since now we are doing this in Excel, let us just do it from here. 6x plus 4y. So now they are inequalities, but where they cross, that's where we want. So I'm going to use equals 62,000. And the next one is going to be 2x plus 5y being equal to 50,000. Now, how we solve equations of this sort is just by multiplying by eliminating. So if I multiply the second one by 2, I mean by 3, this means I'll still have this one. But then the second one now is going to be 6x plus, so what is, so we are doing the second one. So 5 times 3 is 15 is equal to, so 50,000 times 3, 150,000. So when you have now these two equations and you subtract them, you end up by having 14 minus 4, that is 10y, being equal to 150,000 minus 62,000, which is
Excuse me, sir.
Yeah.
Why are we using 3?
Now this is solving simultaneous equations in mathematics. Okay. Why we are using 3 is such that we make these two equations have the same x here term, such that when you subtract the 2, this one goes out.
It gives you a 0.
Yes, so that you only now have to deal with y.
Okay.
Yeah. So now you see that I have here that 10y is equal to 88,000, which means that now y is equal to 8,800. Okay, when you divide by 10. Now, what are they asking us? They're asking us for y. Okay, so because they're asking us for y, we can actually just stop there. Okay, can actually just stop there. So if we stop there, I think if you multiply this is 15, not 14, I must have put a 4 accidentally. So this is 15y. So when you subtract, this one becomes 11y, not 10. So when you divide through 88,000 by 11, you get actually 8,000. So that means that the answer that you're looking for here is 8,000. Now, this one, they asked us to get y, so it's easier to put that y. But what if they wanted x? Now you would come and say, after I have y, then you use n of this equation here. So if you use the first one, this implies that x is equal to 62,000 minus 4y divided by 6. Okay, this is again mathematics that I want you to be able to do it, but I really can't start explaining so much of it. But I trust that you know how to solve simultaneous equations. So 62,000 minus 4 multiplied by your y, which is 8,000, divided by 6 gives you x. So actually x is 5,000. But they didn't ask us for x, they asked us for y, so you didn't have to do this step. Just in case they ask you for x some other time. Okay, that is how linear programming works. And you see this another question again for linear programming. You can tell from the fact that they are giving you two inequalities. And they're saying that this jewelry company makes rings and necklaces.
Another thing, sir.
Yes.
Could you please guide me on how to do the equation on my calc?
Is your calculator scientific? Does it solve equations?
I have no idea.
Yeah, that's now the problem, because most cases people don't have those calculators that solve equations, especially. But what you can do, you can take a photo of it and WhatsApp me. I see it.
Okay.
Can I just wait for you to do that?
It's okay. I can do that right now.
Okay.
I've shared it.
Yeah, you have seen it. This one cannot solve. The ones that solve, yeah, it can't solve this. This one can't solve. So when you have this one, you would have to go through the steps that I've shown you here. Okay, so
Could you
basically,
please recommend a calc I can get that would solve that?
yeah, if you can look for Casio FX 991 MS or Casio FX 991 ES, but be aware that you find those calculators with those figures, but they won't be the real calculators. The original calculators, you know them because they cost about 100,000 plus. Okay, so
Okay.
yeah, they have to be able to solve equations, but I don't know how you'll be able to procure one if you don't know what you are looking for. But these are the ones that can do that. I don't know.
I think when I go to the shop, do you mind if I take a photo when I reach there and send to you?
It's okay. You can reach out to me and I see.
Thank you.
Okay. So going back to this question, so they are saying that a jewelry company makes rings and necklaces. So they have also identified these are the inequalities for the resources that are available. And the management accountant has used linear programming to determine that R is 500 and N is 400. So here they have solved it for you. Okay. So now they are saying which of those ones is a slack resource. Now, a slack resource usually means a resource that you have in excess. Okay, ideally, it's the opposite of a limiting resource. So here they have given, remember the sources that we have is labor and machine availability. And they are trying to figure out which one is the slack resource. So what do you do to determine that? So we have the equations that 3R plus 2N me use capital R so that it doesn't. So they are saying that 3R plus 2N should be less or equal to 2,400 hours. And they also told us that 0.5R plus 0.4N is less than or equal to 410 hours. Now, this first one is for labor time. Second one is for machine time. Now, what you do to determine if you have slack, you already know that R is 500, N is 400. Therefore, you can actually calculate 3 multiplied by 500. So R is 500, yeah, 500. And then you multiply 2 by the 400. So that's what you are going to calculate. So let us see actually. Sorry. So let us see what it gives us. So what does it give us? Gives us 2,300. Then you can also do the same for this one. 0.5 times 500 plus 0.4 times 300. What you can do is to, again, when you get a calculator, you practice solving these ones. Okay, but for now, they gave us the answers, so we are just using them. But you see that you get 370. Now, you can see that they told us that this for labor time, we only have 2,400 hours. And our function is only using 2,300. So we still have time in terms of labor. Even for the machine time, we have 410 maximum, and this one, which we have found, uses only 370. Therefore, when you compare, because they're asking us which of the following is or are a slack resource. So given that both of them seem to have some slack, okay, we are not utilizing on the dot, okay? And let's just confirm that I use the right figures. R is 500, N is 400. So 3 times 500 and 2 times 400. That is 2,300. Then 0.5 times 500. For this one, I used 300, not 400. Okay, so when we change this to the right figure, okay, now we realize that this second one, we are exactly using the 410 as they have told us the maximum, and this one we are not finishing. Therefore, labor time is the slack. So it means that when you finish doing this, you still have some few hours of labor time that you can use. That's what it means by having slack. So on the other hand, machine time is limited, is the limited resource, because what we have and what we need is exactly this. We have exactly what we need and what we have. Therefore, we can't afford to spend any more time on the machine. So this one is the limiting factor. This one is the slack resource. Okay. So that means that our answer is A on this one. Then we have also here, Q makes two products, the cone and the Q1 and the Q2, and they use the same raw materials. selling price and cost details are given to you. So they are asking now for the shadow price of the materials. If materials were limited to 2,000 per kilo, 2 kilos, 1,000 kilograms per week, and you are choosing from here. Now, shadow price, if you remember from the video, I'm sorry, I think my router keeps restarting. I don't know why. I don't want to switch it off for today. So, but anyway, I don't know where I had stopped. I was starting question 95. Okay. So, and they are asking us for the shadow price of the materials. Before we proceed, when we don't cut off, is there a connectivity net problem that side? Can you hear me very well?
Yes, I can.
Yeah, because I realize the network is okay, but for some reason it restarts the router and then I just realize I'm off, but I will sort it out after here so that it doesn't happen again for the next classes. So,
Right.
so they're asking for the shadow price. And I was saying that the shadow price, okay, in actual sense, when it comes to saying something is limited, it's not always really the case. Nothing is really limited. The only thing that is limited is the money that you can use to get something that is limited. For example, if you are working and you realize that you have limited labor, what you can just do is to get some more people to come and work that day. You can actually call in some people to come and work overtime. You could call your friend, your company affiliate to send you some people. Like, it's not really that there is limited resource. It's just that for you to do that, you might need to incur more money to have that happen. And there is such a thing as not being worth it, because if you bring in more people to work, that means it's going to cost you more, and therefore it's eating at your profit. So the shadow price basically represents that maximum that you are willing to add on to get an extra. Okay, to get an extra. Now, for you to determine how that's going to be the case, you need to know which one is limited. So we have a Q1 and Q2. So if we have to first determine what is limited, so we are going to have Q1 and then Q2. So as we said, we have to first determine contribution by unit. And the Q1 contribution is going to be 20 minus 6 minus 4. Or they gave us already 8 and 8.5. So this is good. They gave us the contribution. So now, and we want to get the shadow price of the materials, which means that we are going to look at the materials. So materials, and in this case, actually, you don't have to do this because you can clearly see from here that they both, how many kilos do they need? Okay, you see, if this is $6 and each dollar is 2 kilograms, it means that if you divide 6 by 2, you get how many kilograms? And the same thing here, 5 by 2. So it means that for Q1 you need 3 kilograms, for Q2 you need 2.5 kilograms. So then therefore you can get contribution per kilogram of material, which is basically division of these two. And you see that when it comes to ranking, Q2 will be number 1 and Q1 will be number 2. So now, because Q2 is number 1, if you were to spend an extra amount of dollar to get more material, it would make sense that you get the material to make more Q2, right? So the shadow price should be the contribution per unit divided by the 2.5, which gives us $3.4. This is the shadow price. Now, this is the price that you are willing to pay if it can get you an extra kilogram of material to use on Q2, which gives us more contribution per kilogram. So in this case, we don't have an example which looks at when we are referring to when we have linear programming involved, but we shall get one. But the idea stays the same. The shadow price is that extra that you would be willing to pay. Although the one that is for linear programming involves a little bit more steps compared to this, and we are going to find it as we go. So now here, exactly they are bringing us again shadow price, but here they are not telling us to calculate it, but they want us to say what shadow price is. So shadow price is currently $8 per hour for skilled labor, and they're asking us what does it mean. So now, the first one says that the cost of obtaining additional skilled labor is $8 per hour. It is not exactly the cost, but it is the maximum that we might be willing to pay. Okay, so that's not the case. Then there is a hidden cost of $8 for each skilled labor activity work. That's not true. Shadow price doesn't mean hidden price. Okay, that's just a trick they are trying to pull out on you. Then contribution will be increased by $8 per hour for each extra hour of skilled labor that can be obtained. This is exactly the correct one. So if you have a limited resource, the shadow price is that extra that you are willing to pay. And the reason why it is the extra you are willing to pay is because if you pay that extra, it is going to increase your contribution by that same amount. So if you are able to pay less of that, that means you are making a profit. So that's what shadow price means. And also this is not the correct one. It's not about reducing the cost. So that is shadow price. And I hope here, okay, here they are not also asking us to calculate it, but they are telling us that we have these products or the services, and this is the fee charge, and then they are giving us the costs. And all of them use the same type of labor, which is paid 25 per hour. And they're saying that the fixed overheads are general fixed overheads that have been absorbed on the basis of machine hours. Now they're saying what's the least and most profitable use of direct labor, which is a scarce resource. So this is basically what we did before. We just need to rank these resources. So let's get to ranking. So service. So you have service R, S, and T. And what you need is contribution, first of all, by unit or per service. And I'm just going to make these ones go this side. So contribution per unit or per service, we have 100 minus 15 minus 20 minus 15. For R, then for S, 100 minus 30 minus 35 minus 20. And then for T, 160. Oh, did I say 100 here? This is 150. So here we have 160 minus 25 minus 30 minus 22. Okay, so we have our contribution. So 50, 65, 83 per unit. But remember, what is limiting is labor. So we need to know labor. Labor has been given to us here, but we know that the hours, we need hours. So labor hours. So as we said, labor hours, since we are incurring $20 and we are paying 25 per hour, it means that if we divide 20 by 25, or we can actually just use, because they are using the same labor, we can just actually use the labor per unit, right? So if we bring in the labor hours, so it depends, it's going to give you the same ranking.
Yes, sir.
Yes?
Why is it that on when we're subtracting on the services, on service 2, we're subtracting with the overhead, and the rest we're not?
Now we are doing overheads for all of them, but the variable overheads. Okay, if you check here, the last one is 15, which is this one. Then the next one, the last one is 20. So we are doing so, except for the fixed overheads.
Okay.
Yeah. So when it comes to the cost for labor, since they are using the same labor, you could use the labor hours, or you can bring the what? The labor hours, or you can bring the cost itself. So if I'm going to bring the labor hours, I will say, because if I'm incurring 20 and the hours for 25, that means I do 20 divided by 25. That gives me 0.8 hours. Then I do 35 divided by 25. I get 1.4 hours. Then I do 30 divided by 25, which gives me 1.2 hours. If I do it like that, then I can now say contribution per hour. So by dividing, so that is 62 and 46 and 69. So which means that when I'm ranking them, I start with 69, then 62, and finally 46. So it means that T will be ranked number 1. So rank number 1 is the most profitable, which is T, and the least profitable is S. So which means the answer here is going to be D. Okay, so most profitable T, least profitable S. Then we have another linear programming question, and they're saying that they have made a programming model for 2 products, X and Y. Objective function is depicted by the formula C is equal to 5X plus 6Y, where C is the contribution, X number of products to be produced, and Y number of products of Y to be produced. So each unit has 2 kilograms of material Z, and each one 3 kilograms of material Z, and the cost is $2 per kilogram. Shadow price of material Z has been worked out and found to be 2.8. Now they are saying, so here they have done all the math. They are just trying to ask you about shadow price. If we have an extra 10 kilograms of material Z at $2 per kilogram, what will be the maximum increase in contribution? Okay, and the answer is just the shadow price multiplied by the 20 kilos. Okay, because we said the shadow price is the maximum amount by which the contribution is going to increase if we get an extra kilogram of the scarce resource. So this is just basically saying 2.8 multiplied by 20. Okay, and if you do the math, I think that's going to become 56. Okay, so that means it will increase by 56. Oh, I selected the wrong choice. Increase by 56. Okay. So what you notice that I have not touched these $2 per kilogram. Okay, because they wanted us to get the maximum increase in contribution. But exactly what ends up happening is that since I've spent $2, then this will not be the contribution that I'm going to add. Okay, I will actually end up only having 0.8 because I was supposed to increase by 2.8, but I paid $2, so it's going to increase by 0.8. But they asked for the maximum, so that's why we don't look at this figure at all. Basically, they were trying to ask us to determine the shadow price, but for all the kilograms, not just the one. Then we go to this one. An organization is experiencing a shortage of resources and has graphed a potential linear programming solution, which shows its first product televisions on the horizontal axis, and the other product, the tablets, on the vertical. And this ISO contribution line to solve the linear programming is very flat and downward sloping. Now, if you want to visualize this, you can actually try to visualize it. Basically, what they have done is that they have put on the horizontal axis the first product, television. And then they have put on the other one, tablets. And the equation is very flat and downward sloping, like this. And now they're asking us that which of the following statements is likely to be the true for the company? And the answer, they have given us options. The contribution per unit of the tablet computers must be higher than that for the television. Let's see. Contribution per unit of the television must be higher than that for the tablet. Contribution per unit of each of the tablets is very similar. And contribution per unit of one of the products must be negative. And now, they say that it is very flat and downward sloping. It means, sorry about that again. So we were saying, what does that tell you about the contribution per unit of tablets and that of the television? So because the slope is actually giving, you're saying that because it is flat and downward sloping, it means that what you put on the vertical axis, remember they told us that on the vertical axis they put tablets, and on the horizontal they put televisions, and the curve was going down like this. Now this is called an ISO contribution line. It means that this is a line which is drawn to show where the contributions of two products is the same. So if it's going downwards like this, it means that the one on the vertical has a higher contribution than the one on the horizontal. Because you see that for you to reach the same contribution for the tablets and television, you have to slope downwards, because this one the tablets have a higher contribution compared to the. So I have hotspotted on my phone. I want to, let's first leave this router alone, because I don't get its increasing frequency. So what I was saying, that when you have that line sloping downwards, if it's sloping downwards like this, where this is televisions and here I have tablets. It means that for you to reach the same contribution where televisions and tablets are concerned, the curve has to move down because the tablets have a higher contribution than the television. So, which is what the first statement here says, that the contribution per unit for the tablet is higher than that of the televisions. So that's why the curve is very flat and downward sloping. So, if we move on to the next question, a linear programming model has been formulated for two products A and B. Now, what you have to remember, maybe I'm not saying it as often as I should, linear programming is not going to be asked of you in section C as a calculation, but they can ask you to maybe let's talk about it, basically what it means, how it is done, the steps, okay? But section A and B, you can see they also can give you things to discuss, but also things to calculate. But they will never ask you to do a linear programming from scratch. So just have to know how to do things like solving those equations when they give them to you, finding the scarce resource, and also by the same logic, the one which is slacking and shadow price. So here they are saying that linear programming model has been formulated for two products, and they're asking which two of the following statements are true. So because there are two products, the first statement says that J can use linear programming if it starts to manufacture another product C. So this is not true, okay, because the thing is, we have to only use linear programming when we have only two products, because the equation that we have been using have X and Y, okay? So they are not possibly able to actually solve this when we have three unknowns. So because what you end up having is not a line, but a surface or a curved line, which it's not going to be something that you want to be dealing with. So if you have only two products, you can use linear programming. If you have a third product, you can't use it. What you can use is what we can call simulations, okay, where we actually go on and look at computer simulations. That can be done, but not on the paper, and no one will ever ask you to simulate in accounting unless you are an actuary or some other person who is really looking at complex financial systems. Second statement says, J would need to use linear programming if there was not a demand constraint. Really not the case, or would not need. That's not true, because the thing about linear programming is that you need to have more than one limiting factor, okay? And that limiting factor doesn't have to be demand. So here they are saying if demand is not a constraint, you can't use linear programming. No, you can. It could be that demand is not a constraint, but materials and labor are, in which case you can still use linear programming. Then third statement says, J should ignore fixed costs when making decisions about how to utilize production capacity in the short run using linear programming. This is true, and this is true for most decisions that we make. We don't look at fixed costs, and I think you may know why, because fixed costs will be costs that you're going to incur regardless of whether you produce less or more. So basically it ends up not making sense for us to even worry about them. So we figure we just keep working without focusing on them. So this is the right statement. And if you look at the last statement, a linear programming models can be used when there is an experience curve once the steady state has been reached. Now, I don't know if you know the experience curve, but this is referring to what we call a learning curve. Okay. Now, when you are making things by hand, not using machines, let's say you're making baskets. When you start making baskets, you are not so good, so you make at a slower pace. But by the time you reach some point, you have now reached, you now make more per minute than you made before. So that means that now you are learning what works best. And after you learn and reach the point of maximum learning, that's what we call steady state. The learning stops, and then you now who have maximum capacity, you'll be working basically now something that is predictable. They know you can make 2.6 per minute. That's where you work. So this is a correct statement. Once we reach the steady state, it means that now you have stability, and therefore you can predict. So that means you can still use linear programming. But before we reach steady state, you can't use linear programming when there's still learning curve, when learning is still happening. So that is something that you might know. So another question here, which basically looks like what we solved before. They have given us contribution, and they have given us a graph which has shown that this is where the line actually, where those two lines cross, that's where we are going to have our optimum production plan. And basically what we are doing is to solve this again, and we are looking for A. So let us go solve it. And as I said, in this case, once you have the calculator, you can solve it, no problem. We shall look at how that is done. But for now, let us solve it the mechanical way. So A plus 2B A plus 2B is equal to 8,000. The next one is 2A plus B is equal to 13,000. So now we want A. So since we want A, we can remove B. So if I multiply this thing by 2 down, this one stays the same. But now this one becomes 4A plus 2B is equal to 26,000. Now when I subtract them, the B's will go away. So then when I subtract them, I get 3A is equal to, so 26,000 minus 8,000 gives us 18,000. And then that's for, if you divide by 3, you get A as 6,000. And the answer is C. So I hope that gives you confidence that you are able to do this with your calculator or without, because it's, now this is how these graphs can look like. They have given you this graph, and they're saying that all constraints have less than or equal to constraints. What is the maximum number of units produced of B, which can be produced of product B? Now, because all of them have, you see, this is the product A, this is product B. Product A is here, product B is here. Now, if you are doing this on a piece of paper, you know what we said, we shade the unwanted region. So you would shade this part, because they all have less than or equal signs. So it means that the part that we want is the less than, which is the interior part. So you would shade that part like that. Then you would shade on this one also like this. And then also shade this other one. So you realize that after shading all the unwanted region, what you remain with as the triangle of interest is this one here. And I don't have a good, okay. Okay. And this one here. That's the triangle of interest. And they're asking the maximum number of units of product B. So you go to product B, find the maximum under that triangle, which is 60 units. So the answer here would be 60 units. Now, I'm not focusing so much on this graph, but I've just shown you how it works. But the one that has much more going on is this one here. But still, you don't have to know how to draw it, because as I said, this is something that they don't expect you to do in Excel or in the exam, but they can give it to you here. And they're saying that this organization has created this, and they have created it, and they are saying the point marked B, this one here, has been determined to be the point which provides the optimal solution. And they're saying which of the following sources will have a shadow price greater than 0. Now, if this point B, this one right here, if this point B here is the optimum point, and they are saying which one will have the shadow price. So you realize that if we are on this point, we have, now you see the maximum of A is this side on this line. And then here, we have it here for R. So now we want to find what the optimum price is. So where is the curve? So let us see the curve very well. Let me just move it a bit. So to know where the shadow price is going to be, we are going to see these lines. This one is for material B. It doesn't reach here. So it means that there is slack, okay? We don't use all of it. Because remember, this point here is our point where we have the optimal solution. So materials don't pass there, so we don't use all of them. Material A as well doesn't pass there. Machine hours don't. But the direct labor hours line is the one that passes on the optimal point, which means that direct labor hours have a shadow price because we are on the point. When we are here, we are utilizing all of them. So it means that if we need to actually get more, we need to pay a shadow price. So the answer in this case is direct labor hours. Okay, those are the ones that are having a shadow price. Whereas material A, B, and machine hours, those ones we can say that they have slack. Okay, is that clear?
Yes, it is.
Okay, so let me see if we have limiting factors in section B so that we can also handle those ones. Okay. So we have done the limiting factors in section A under decision-making techniques. So it's going to be in these questions here. Okay, but I have not ahead of time determined which ones are for limiting factors. So let's just go and find them together. Okay. Okay, so we have a question here, which is called Caraco. But before we do it, I think we should take a 5 minutes break. Don't you think so?
Yes, please.
Okay, let's take a 5 minutes break. So we come back at 8:20.
Okay.